Good morning, everybody. So yesterday I started introducing you to how to actually calculate a z-score, a p-value, everything you would need to create a significance test for a proportion. Now what we're going to do is kind of formalize it a little bit. If you remember in confidence intervals, I showed you guys the state, plan, do, conclude. The exact same thing is true for significance tests. Okay, so it's still state what you're trying to test, plan it out, check your conditions, here's what I'm going to do. The do is the actual like math part. Show me how you got your z-score. Show me where the p-value came from, so on and so forth. And your conclusion is, I failed to reject the null or I reject the null. Okay. So one thing I want to let you guys know, a significance test for a population proportion is often referred to as a one sample z test, okay? So here's the difference. You remember back in confidence intervals for Unit 7, it was one sample z interval, one sample t interval. So the only thing you're changing is it's a one sample z test because we're testing for p. We're not finding the interval, okay? But otherwise it's called the same thing, which is kind of nice. But just test versus interval. Is it a confidence interval or is it a significance test, okay? So here's an example problem. My husband and I actually really like watching Survivor. Right now we're watching season 40, which it's really good because it's all the winners from like the past 40 seasons. Like they got a bunch of them. And anyways, I'm geeking out over it because it's really good. Anyways, so this problem says television executives and companies who advertise on TV are interested in how many viewers watch particular shows. According to Nielsen ratings, Survivor was one of the most watched television shows in the United States during every week that it aired. An avid Survivor fan and textbook author claims that 35% of all U.S. adults have watched Survivor. A skeptical editor believes this figure's too high. He asks a random sample of 200 U.S. adults if they have watched Survivor, and 60 say yes. Is there convincing evidence at the alpha of 0.05 significance level to confirm the editor's belief? Okay, so we got a lot of things going on that we need to unpack before I show you what this would all look like, okay? First thing, here's the claim. That means that's our null, okay? That the proportion of people who watch Survivor is 0.35, okay? Our p hat, okay, is 60 out of 200. So off to the side of my calculator, I'm figuring that out. So p hat is 30%, okay? Also, before that information was gathered, the skeptical editor believed the figure was too high. So the skeptical editor is saying, no. I think it's less than 35%. That seems high. So there's that alpha, okay? Then what we're going to do is we're going to say, okay, what's the probability, what's the p-value that they got this sample proportion that is truly smaller than the 35% purely by chance? Then we're going to use that p-value, compare it to the significance level they chose, and say we have convincing evidence or we don't have enough evidence to disprove it, okay? So here's how this looks. It's going to be a lot of information on this next slide, but you can pause the video if you need to. But this is the like formalization of what it looks like. Okay, so the state, you have to write out in complete sentences. We want to perform a test at the 0.05 significance level of blah, 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 right? This is the blah, 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 where P equals the proportion of all US adults who have watched Survivor. So a couple things you need in the state. Number one, you have to have the significance level. You have to state that prior to doing any calculations. Otherwise, you could just pick your significance level later based on, I do want to disprove this, so I'm going to make it higher or smaller. You can't do that. You got to decide it ahead of time. Okay. You also have to say your null and alternative, which I think is obvious. But the other one is you have to say, what is P standing for in this situation? So basically context, right? Like refer it back to what are we actually testing? Then for the plan, you say, okay, as long as everything works, I'm going to do a one sample z test. Okay, I'm going to check my conditions. Is it random? And use the word random, so yay. And I check my large counts. Again, just like yesterday, notice how they're using the actual p-value. Don't use p hat like we did for confidence intervals. Okay, if they give you the actual p-value, use that. If they don't, that's when you use your p hat. Okay. Now look at your do. That's just all the calculations. So here's our p hat. Here's our z-score, where it's our data minus the null hypothesis, what they think is true, divided by the standard deviation. And then using that z-score, they did normal CDF and got this p-value. So here's our conclusion. Because the p-value of 0.0694 is greater than our significance level of 0.05, we failed to reject the null. There is not convincing evidence that the proportion of all US adults who have watched Survivor is less than 0.35. Here's the part that's big. There is not convincing evidence. Our p-hat is in fact less than 0.35. So we have some evidence, but it's not convincing enough to completely go to that other editor and say, hey, your 35% is wrong, mine is more correct, right? You need to have more to support than that. So I wanted to show you guys, this is my version of it written out. So you can see there's a couple things I have a little bit different. The state looks almost exactly the same. The plan, I actually check the conditions first and then say what the one sample Z test, so it doesn't matter, okay? But the reason I wanted to show you guys this is because of the do. So basically what I did was I did everything kind of by hand. And when I did everything by hand and got the standard deviation, I rounded a little bit more than what they did on the last page. So I got a z-score of negative 1.47. The last slide, they got a z-score of negative 1.48. So depending on whether you're using, like if you're rounding a little bit more than I am on the answer key, or maybe you're using technology versus the table, you might get slightly different numbers than I do on the answer key. That's okay, because notice, when I used a z-score of negative 1.47, my p-value was different. I got 0.0708 instead of the 0.06 blah, blah, blah we got on the last slide, but it's still greater than 0.05. I still fail to reject, and I say we do not have convincing evidence, okay? So please know that when you're going through this process, that if your numbers are a little bit different from mine, please don't panic. That's totally normal. All right, one thing I want to talk about is a two-sided test. So up to this point, we've been doing, okay, here's our null, like for the Survivor one, for example. We thought it was 35% as Survivor fans, and then the other editor was like, nah, I think it's less than that, okay? A two-sided test is, let's say the first editor still says 35% of people watch Survivor, and then the editor says, no, I just don't think that's true. We do what's called a two-sided test, meaning the other editor doesn't care what the actual proportion is. He's just kind of like, I just don't think it's 35. It could be bigger than 35, or it could be less than 35. So that sounds scary, and it sounds like, oh my gosh, you're adding this whole extra twist. But really, almost everything is exactly the same. So let me show you. Okay, notice how the alternative has the p is not equal to 30%. Okay, so what they're going to do, we got a simple random sample, 19 successes out of 50, so there's our p-hat. We're going to calculate the p-value, do everything in the table. I'm doing this part quickly because this part I've already kind of gone over. I just want to show you the big difference between the two-sided versus one-sided. Okay, you find your p-hat, you find your z-score, and here's the only difference, okay? When you get your p-value, right? We would say, okay, so 1.23, upper is 1,000, and so on. I disagree with that. That should be negative 1,000 to negative 1.23. So I'm not sure why they used positive. Kind of ignore that part. I think that would screw you guys up. I would use less than that z-score. But notice how they put this times 2. Here's what that means. Essentially, we're saying, okay, here's my z-score of negative 1.23, and we're finding the probability. Well, the reason we would find this probability is we'd say, I think the probability is less than this, so what's the chances I got this p-hat or less purely randomly by chance? Well, if I'm saying that I think the null, it's anything but the null, it's called two-sided because not only am I saying I think that p is less than that number, or I think p is greater than that number. So what essentially you do is take that z-score and find this probability over here. Well, since it's a normal curve, whatever this probability is, you just times it by 2 to get the other side. Okay, so that's the big difference. If it's a two-sided test, it's just twice whatever you get in your technology. Okay, so here's a good example. Okay, where basically the idea is whatever your z-score is, you're looking for, well, I just think it's either this or this when it's two-sided. So everything's the same except you take your p-value and multiply it by 2. Okay, so here's a problem for you guys to look at. Go ahead and pause the video and just kind of read through it, think about how this would work for you. All right, so the question says, is there convincing evidence that the proportion of all students at Anton's school differs from the national result? It doesn't say they think it's bigger than 59%. They think it's less than 59%. It just says, I think it's different. Notice how the alternative is a two-sided test, okay? If you pause this slide, everything else is exactly the same. You do your conditions, it's a one sample z-test, here's my p-hat, here's my z-score. Again, they're doing that really weird, doing that number and bigger, and I don't know why. But essentially what you would do, right, is normal CDF, negative 1,000, comma, negative 2.24, comma, 0, comma, 1. And when you type that in, then multiply it by 2 because we're saying it's either bigger or smaller, and I don't care which one. I just think it's one of those, okay? That's where they got this p-value from. So that's the only twist I'm adding, is if it's p is less or p is greater than, it's a one-sided test, and you just do that z-score and bigger or that z-score and smaller, depending on what you're looking at, okay? If it's a two-sided test, whatever your p-value is that you get, just make sure to multiply it by 2 so you're representing it could be bigger or smaller. Okay. I don't think... Oh, yes, this is the last piece I want to talk about. Let's read through this slide together. The result of a significance test begins with a decision to reject the null or fail to reject the null. In Anton's smoking study, for instance, the data led us to reject the null hypothesis because we found convincing evidence that the proportion of students at his school would say they have never smoked a cigarette differs from the national value. So we're left wondering what the actual proportion might be. So here's what I mean by that. If you can reject the null, okay, you've rejected the null, but you haven't actually proved that your p-hat is correct. Right? Like you haven't actually said, my p-hat is now the new null. That's not the case. You've only just said, I have enough evidence to say the original statistic might be false. So what we can do is a confidence interval could shed some light on what is the actual p. So now we're going back to Unit 7. We can then create a confidence interval using the statistic we have, figuring out what percentage we want, and say, okay, yeah, I reject the null hypothesis before, so now I'm going to use my p-hat and say, I think the true proportion, the actual p, lies between 0.605 and 0.755. So you'll notice on today's homework assignment, part 2, one of the questions you will reject the null, and then I will ask you to say, all right, given you rejected the null, what's the confidence interval that could estimate the actual p that we're looking for? So you'll see kind of a connection between this unit we're talking about and the unit that we just got done with. So kind of cool that it all connects together, right? Now, don't forget though, make sure that you're using, notice how in this case, they're using the p-hat, right? The 0.68 or the 68%, not the 59, because we just disproved p. We disproved p is 59%. Now we can use our p-hat and go from there, right? Because we're estimating what the true p is, okay? All right, you guys, so today you're going to be working on part 2 of that homework assignment. Just like yesterday, it's 3 questions, but it's more so formalizing it, giving you practice with the state plan, do, conclude. Feel free to stop in for office hours if you need something kind of clarified or if I can help you with any of those homework assignments, okay?